So before I start, the purpose of this video is for educational purposes only. I am using my own test environment. Obviously the operating systems I'm using are local to my machine. So only testing for educational purposes and discovery only purpose within ethical bounds. Obviously anything that you use these for should be within legal ramifications only. Okay, thanks for watching. Hi everyone, in today's video we're going to be looking at some advanced arguments that we can apply to the Nmap tool. So we've already covered the basics of Nmap and one of my favourite commands within it. This video we're going to be going forwards looking at some advanced arguments, how we can really customise our payload to either expose ourselves or really hide ourselves, and we're doing it from a different perspective. So on the left here I've got my Kali machine which I'm going to be using Nmap on. So on the machine on the right, I've got a Windows 10 machine and I'm running Wireshark on it, Network Analyzer. So I'm going to be seeing what the payloads we're delivering are, and obviously us seeing the other end from the defender's side, or even the sort of the vulnerable machine side, is we're going to see what's coming through and ultimately what packets we're sending and whether we're giving ourselves exposure or not on the other side. So we can really use the advanced side of Nmap to customize the packets we're sending to the target machine. So here we go. So I'm set up with my virtual machine, my Windows 10 machine on the right hand side. Run a quick IP config just to see what its static IP address is. So 192.168.160.175. 174 is the Kali box. I'm just going to ping that. So that's pinging fine. That's seeing it. Obviously, we already can start seeing our TTL is 64. So that's a return, and 64 is based on the operating system returning, and TTL of 64 is Linux. 128 is Windows. So you can already sort of see our target orientation there. We can change the time to live within our sort of Nmap command. So I'm just going to ping all the way through .175, and ultimately that's not going to be pinging because we've got the firewall turned on the Windows 10 machine. I'm not going to turn it off because I'm going to keep it as a real world environment. So what I'm going to do is see what we can see on this Wireshark here. So we're running Wireshark. We can see 174 is this box, calling at 175 is this box, my Windows 10 machine, and ultimately through the ICMP, which is ping, we can see the payload here. So if I just open this up, I can see that the ping message is simply just sending 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, and then the rest. So it's just a simple ping message, is just information coming in. What the aim of this is, I'm going to stop this now, I'm going to stop seeing the ping messages coming. What the aim of the Nmap is to stop identifying ourselves coming over as 192.168.160.174. We want to be coming fundamentally something as an additional IP address within another IP address within that /24 range. Like, so if I was to come in as 173, which potentially could be a domain controller, for example, I'm going to false that in. I am going to change the IP address off to something totally different, just to show you, just to highlight it within the Nmap. So if I go sudo nmap space -T4, I'm going to go in loud, then Ethernet. You have to, using space -E, we say what interface we're coming out of, and then as you can sort of see, they're already predicted because I've done some pre-testing with this. I'm coming out with a source address, which is -S is the argument, which is spoofing. We will have a look at man Nmap in 2 secs. So 192.168.160.175, and if I run this, what we should see come through is this. So we're starting to see the 69 IP address going through. We're still seeing this source port number, so we're going to be spoofing the port number as well in 2 secs. So I'm just going to stop that running, and we're seeing what effectively the defenders would be seeing within their sort of SIEM or security instant event management viewer manager. So what I'm going to do is do man nmap. So we can look at other arguments which we can use additionally to spoof ourselves further. So I know I've used the 69 IP address here. You can use anything within that just to spoof something. So if we wanted to use the same IP address as the default gateway, for example, that's going to be an IP address which often communicates with this client if this client's trying to access anything through the internet. So obviously it's the router that it would be the default gateway. So I'm just going to move down on this man nmap, so the manual for it, and we're going to go with we're going to be spoofing the port number effectively, and we're going to use a well-known port number because this one here is going to highlight us. There's a few that if you're coming externally in, normally you would be using one of these numbers, port numbers, but we want to use a well-known one. So return from 443, for example. So we can see here -G or -- source port, then the source port number gives the port number that we're going to be using. So that will affect effectively this column here. I've still got the Nmap, I've still got Wireshark running. So if we just do Q on this, rerun our Nmap command with a few additional options. So I'm going for, I'll stick it here, -G, then port number 443, hit enter, and then effectively we're now seeing this come from 443. So if we were using, I'll just quit that. So if we're using an IP address which is on the network and then a well-known port number, the source port, and we would start to get well-known responses, and often we can bypass firewalls with this, or we can just remain a little bit under the wire. Obviously, I wouldn't advise going in loud and proud and scanning all port numbers because you might wonder what a web server being port 443 within that IP address would be. So you would want to customize the source port number based on what the IP address you're pretending to be at the time. So as a part of the command that we've ran, we've spoofed our IP address, we've spoofed the port number, but fundamentally we can still see our layer 2 information, which is MAC address. So if I go over here, I can still see, so the internet protocol, I can see the IP address of 69, I can see the source and destination, but effectively I can still see our source MAC address. That's something within the Ethernet header that gets sent across. So this is going to highlight that it's a VMware, so that it's already being identified as a VMware header because VMware, because of the UIN, the sort of unit identifier and the manufacturer ID, which is the first part of the MAC address. So what we're going to do is spoof the source MAC address we're using to really cover up our entire trail. So if we just Control-C out of that, do man nmap again, just to find this spoof MAC address. And the reason why I keep going back to these man commands is that you can't be expected to remember them all. So use what you've got. So that's why I'm like going to use the same commands that I would use during a CTF, for example. So if I go to, so we can spoof IP address, we've done that. Spoof port, we can spoof the port number we're using. And next thing, we want to be spoofing the MAC address. So a bit further down, I imagine. And there it is. So -- spoof MAC, and then insert the MAC address there. So that's just the hexadecimal we'd have to put in at that point. So using the original command, going back, I'm just going to add it before this -G for the port number. So if I go -- spoof -Mac, I think it was, it might change, but if I go for looking at the MAC addresses on here, so we can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's all those 10 bits there. I'm just going to go for all lowercase. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and it might have to be colons. I'm just going to, yep. So spoof, got the extension wrong. Go back in. So it's got to be colons between, I imagine, because that's what MAC addresses are written up in different ways. So if I'm talking networking and Cisco, then it's a dot, but these are colons. So if I just do that, so now we're through with spoofing the MAC address, and if I just stop this and then look at what packet we're sending, we can see at that point we're now all A's all the way through. So you can effectively use the manufacturer identifier, which is the first 1, 2, 3 for 6 characters of the MAC address, which is the manufacturer identifier, and then you can map that to whatever you want it to be. So we're sort of starting to really clean up our out signal and our payload. We're not customizing what information we're asking for, we're customizing the sending at the moment. So what I also want to hide is our TTL, because our TTL can identify the other side of what operating system we're coming from. So our operating system we're coming from is 48. And if I just go to Google a minute, and then, so if I search on Google, operating systems default time to live, 64 as mentioned earlier is Linux, 128 is Windows, 255 is Cisco routers. So if you're going through any routers and it starts going down through the internet, and you can do a trace route for that, you can see each router will take off a time to live, because that's what the rule is, to prevent loops of data. And that's what time to live's for. It's a loop prevention mechanism mainly. What this nmap command is doing for us is actually changing that time to live. So we're it's evading what operating system we are. So if obviously we're utilizing a Linux, so that's going to be 64, but if I did set it to a Windows machine, so I could then well and truly take the characteristics of a Windows machine, what I'll do is I'm going to set that to 128. So if I go back into man and want to set the TTL, so let's get the argument. So you'll probably spot it before me. If I go down, so there we go. If I go -TTL and set that to 128, which would be the default TTL of Windows, so Q on that, add that into my argument. So now really specifying, so I'm going to go MAC address, then TTL 128, hit enter, run that a few times and sort of clear that out. Then what we're going to see is, what we should see is 443, time to live 128. So if you're really picking up on forensics of a machine, and it's sort of what you're using to access the machine, where we can see we're using port 443, time to live 128. So effectively that is starting to look like a web server or HTTPS traffic coming in. Cool. That's pretty much it with regards to crafting from the source. I'm going to cover a crafted string next. So to craft a string, we can send a message to the endpoint, because at the minute we're sending out these E's for every port we scan. We're sending out E's. So if we really wanted to sort of get up the nose of someone, we could send a crafted packet there. So if I go man nmap again, and then we go for its string we're looking for. So we can see there it's data string and then followed by the string. And obviously I'm not going to put spaces within that, because the string should be sort of one continuous line. So data string. So if I go back to our original command, which we're now expanding on, and I'm going to add it towards the beginning, and I go data string then followed by the string. Hello from the other side, for example, hit enter on that. So we're running our command. If I just hit Control-C, stop that. And then what we should be able to see is our message appear. So we can start seeing that appear. So hello from the other side, the IDE side. So we can send our crafted packets to the other side. So that's sort of our message that we're sending. It's still doing the function of the Nmap So it's not going to adjust the function, it's just sending a crafted packet to anyone who is viewing these pcat files on the other side through a seam. So if you are in a training environment and someone is on the other end and you want it to really sort of get under their wigs and it was a part of a capture the flag exercise, you could really do that using that command. So what I'm going to start doing, instead of just using these now, so we've really honed in on hiding ourselves quite well with the source IP address, TTL, the MAC address, so we've hidden our sort of characteristics, I suppose. I'm going to start playing with this side. So instead of just sending out a message and scanning and all ports and doing OS scans, we're going to be a bit more sophisticated with things like scripts, for example. So you can run Nmap a lot more times. I know it's an active reconnaissance step, but effectively running these scripts, we can get more information. So I'll see you in a second.